So now I'm going to show you how to calculate the perimeter of a sector. Notice that we're using the word perimeter. So we don't just have to calculate the circumference, we need to then add on 2 radii to close the shape. So we have exactly the same shape as we calculated the area for earlier. Notice that because these are both radii, one radius here, another radius here, this length is going to be absolutely identical to this length, and it's worth making a note of that so you don't accidentally forget. If we need to work out the perimeter, we're going to have to calculate this arc here, and then we're going to have to add, sorry that's really badly written, we're going to calculate this arc, and then we're going to have to close it by adding on our 2 radii. And this is how we do it. First, what we're going to do is just calculate the circumference of a circle with a radius of 7. So we would do that by timesing pi by its diameter. Now at the moment we have its radius, so actually I'm going to label that r, and then underneath I'm going to double that and label it diameter, so that I don't accidentally use my radius when I shouldn't. So this is going to be pi times 14, which written grammatically is 14 pi. Now I know that the entire circle is worth 14 pi. I need to calculate the proportion that I have. Now, out of the possible 360 degrees in a circle, if you stood in the middle and spun around to face the same way, you would have to travel 360 degrees. I've only travelled 51 degrees. So I have 51 degrees out of a possible 360. So what I'm going to do to calculate this arc, which would basically just give me this part of the circle, I need to times my 14 pi by my 51 parts out of a possible 360. And I'm going to label that arc so the examiner understands that I know what the section of the outside of a circle is called if it's not a full circle, and also it helps me keep track of my workings. Once I've got my arc, I need to add on my 2 radii, because at the moment I've only just calculated the curve of the shape. Now I need to add on 2 radii to make sure it's closed. So I have to add on 14. So my area of my sector equals my arc length plus 14. So let's now type all of this into a calculator. Notice I write a lot of extra detail, I label everything. So in my exam, if I do have to leave it and come back to it, or I have time to check it, I can follow my logic really easily. So we have 14 pi times 51 out of a possible 360 degrees. And then I'm going to add on 14. So we end up with 20.23, and that's what I'm going to round it to. So 20.23. Now I haven't given you a unit here, so I'm just going to put unit. Okay. Now if this had been centimetres, I would have written centimetres here. If they don't state what the unit is, just put units. The same thing as, for instance, if you had an area, you should always put units squared if they don't specify what the measurements were in. But to be honest, they usually do. So just to recap, if you're working out the perimeter of a sector, just remember you don't just calculate the circumference, you need to close the shape. Calculate the circumference of the entire circle, and then calculate the proportion that you need by multiplying the amount of degree, by multiplying it by the amount of degrees you have, and then divide it by 360. and that looks like this. Then, once you've got your arc length, which is your curved bit on the outside, you need to close the shape to make it 2D by adding 2 radii, and those radii will always be the same length. That's the whole point of a circle, that you start off with an origin and you have the same length distance from it all the way around. Sorry, my circle drawing is pretty poor, I have to say. Ooh, that is really wonky. And that's what makes it a circle, that you have the same distance, all the points are the same distance away from the origin.